Hi, my name is Ivan Milin. I'm a researcher and a scientist, and I'm developing a technology here that is called Milinator technology. Milinator technology came from the nature and came from the space basically, because the idea about developing this technology came from the Russian space program called Trip to Mars. For Trip to Mars they needed a year there and a year back, and apparently they would have to somehow make the system within their little capsule that would imitate the ecosystem of planet Earth. So they would need to have produced food over there to get rid of the waste. The only problem is you cannot throw it out of the window. You cannot throw even 1 gram out of that spaceship. So everything has to be recycled. So when I met them and we started talking about those things with those Russian scientists, I was amazed by the possibility. What is if we take this technology and instead of making it on a minimum kind of level in the little spaceship, why don't we use it here on Earth? So I put the direct questions, why don't we use it here on Earth? So they said it's impossible to make it profitable. The bigger plant we make, the more it costs per ton to produce. This is the nature of the beast and we cannot do nothing about it. We tried for 15 years. Well, this is how everything started. The idea started in my head, I loved it, so I kind of started thinking about that, and I decided, with the blessing of my family, to start doing it. So what was the idea is using flies and fly larvae to recycle all organic waste inside that little capsule. And that idea just can't get out of my head, so I just talked to my wife. We decided, we believe this is the future of this world, and let's do it. So we kind of put our things together, all the finances that we have saved for the old age, and we decided, okay, we're going to spend it on this because it's worth it. So what was the technology all about? Why did we start doing it? I believe that I could do it because, well, Mother Nature is doing it. So what was wrong with the Russian system? Well, the Russian system kind of didn't work because they had to supply the air to the larvae who is working, and they kind of tried to supply it through the tunnel, and they put the conveyor belt through the tunnel, and everything was okay if the tunnel was 10, 12 feet long, no problem. The air that is entering is just about the same like the air that is exiting. So on both sides of the tunnel had about the same air. But the only problem with that was it was very small capacity, because what can you do on 12 feet? Nothing. So we will have to make it 200 feet, 300 feet, 500 feet. Then we could kind of say, well, we did it on an industrial scale and it's profitable. So this is how the whole thing started. The fly that I'm using is just a not regular kind of house fly. They call it Musca domestica in Latin name, but that translated means a house fly. Why house fly? Well, first of all, why flies? Why not some other insects? Well, the insects are known to be carrier of different diseases, some of them more, some of them less. And whatever they make would be full of pathogen, disease and everything else. So it won't be really such a useful thing, especially if you want to use it inside. So the only species of insect that I found are not carrier of the pathogens are fly larvae, not flies, fly larvae. Because fly larvae, they kill pathogens. They eat them and they kill them with their juices. So whatever they produce would be perfect for use. You could use it inside, outside. You could practically eat the things and still it will probably be beneficial to you. But this is one of the reasons why flies are used. Now, why flies Musca domestica? Well, because their life cycle is very fast. The life cycle is only about 10 days under the right temperature, 10 to 12 days. So the faster you make it, the more economic it becomes. First prototype was proper dimensions. I have 6 foot width of the conveyor belt. Well, this is not conveyor belt, but this is something that would become conveyor belt, just for the proving the thing and make sure that everything works as we planned. I designed this. This represents conveyor belts. Each of them represent conveyor belts. They are stationary. I have to kind of move the little containers from the day 1, day 2, day 3, day 4, day 5. 5 days is plenty enough. 4 days is enough, but 5th day is just to make it a little bit better and drier. Then I have to get them fresh and fresh air and a clean air and a warm air. Since I didn't have much money, I made a heater over there. There is a $1 on the garage sale heater. I have regulator over there. I could regulate the heat, the air. I circulated. Here is the fan that I bought in an army surplus area. So I circulated air through the system, and the system sometimes required air that is from the same room, sometimes required air that is out of the rest of the building, because this is kind of not really outside air, it's a little bit warmer than outside, and I could, in the middle of the summer, I could use the outside air. So everything is kind of done very inexpensively. I could have air coming through this way, through that way, or through that way. So I had the regulations. No, I could close this hole halfway, 1/4 or something, so I would regulate the amount of air. And of course I could adjust the air from this little heater here. It has a nice adjustment. So everything else cost me a couple of $100, but it did a good job. So here we are. This is a prototype I made. Well, let's put it this way, I designed it. There is an engineering company, Whelan. They made it according to my design. Very nice people and very good engineers. So we together kind of put our brains together and designed this one, and it's working. There is a lots of little things that I have to kind of fix, but we expected that. And we didn't make it just to produce fertilizer, we make it to test the principle. So I have more things here than I really need in production. So this is what it is. Whelan would be the company who would produce it for North America, and I hope that that would have to start very quickly now, because we have lots of people interested in it. So as you see, the dimensions are right. The dimensions are 6 feet. The length, well, the length we could make as long as kind of possible by the equipment, but it could be, according to some people, I could go to a 500 feet long. So it's a very simple thing, but very useful. But since I was first to kind of go into that principle, I was able to patent things that are very, very simple things. But that's good, because if you patent simple thing, nobody can make it any better or something like that. Complicated thing, oh, you could make it 10 different ways. The simple thing you could make 1 or 2 ways, and that is covered by the patent. So I don't have too many secrets, as I say, because every time people have a secret, that is because if you know what if they tell you what the secret is, you probably wouldn't buy their product. This is the research center in Guelph, the research farm. So they have constant supply of fresh manure for me, and I have my prototype now, and the government sent 2 people, 2 experts, to kind of see what this crazy guy is doing over there. And take regularly, took the samples, interview me, and on the end they fell in love with technology, because when they analyzed it, they realized that I didn't lose any nutrients, nothing went to the air, nothing goes anywhere. I have a perfect recycling system, and here it is. So each of them kind of represented one belt and one day. So I started with day one. The air was circulated not longitudinally. Longitudinally would be this way. This was the width of the belt. Air would go from this chamber through those ducts, get preheated, circulated here, go through it. So my air circulated on the width of the belt, not on the long through the tunnel. So that was the basic kind of change that I made to the Russian system. And then I have another 23 other changes that I patented. So my patent has about 24 clauses, each of them covering a simple part of the invention. So here it is here. This is my whole invention here. You have a bin full of manure, you have a pump that would deposit manure on the top level, you have something that would kind of deposit the eggs that I produce in the cages, so the fly eggs would just fall down as this one was felt, and then it would just sit for a day. You don't have to worry. The workers are there working their way through the manure. The next day you kind of empty the first one onto the second belt, and at the same time fill the first one with a fresh manure. So every day you repeat the same. After 4 or 5 days you have fresh one coming on the first belt every day, and out of the 5th belt it comes the finished product, nice and dry, completely. How do the larvae get out of it? Well, larvae have an instinct, fly larvae have an instinct to come out and pupate, to create cocoons somewhere in a nice, clean and cooler place. Well, that nice, clean and cooler place they never find, because when they fell off the edge of the belt, they fell into the trap, and eventually they just collect themselves inside the bucket. So this was the very basic, very easy system to do, and it could recycle, I don't know, 100 tons per day if you need. All you have to make sure that you have long enough belts. And the length is no longer a problem, because, as I say, I circulate across the belt, and if it's kilometer long, that's fine, because it still circulates only 6 feet, not 1 kilometer. Because in 1 kilometer, if you start with 25 degrees air, it would probably be 19 degrees on the end, because wet manure would cool it down, it would be full of moisture, it would be full of ammonia and who knows what else. So that is the base of my invention. Now I choose to start with the egg layers manure, because egg layers manure have most nutrients in it, because, well, chicken, they do not urinate, and, well, urine comes from the name urine comes from the urea, and urea is a fertilizer. So everything is mixed in a manure, everything stays there, nothing is lost. So I start with that in order to get the best manure possible, so that I could sell it on the market and get enough money to cover kind of the cost of operation, make a little profit, so everybody is happy. Without profit, nobody would use it. So this is the basic idea of how the whole project started. This kind of sketch is your guide of how my prototype would look like. So, as I say, basically a bin full of manure, an auger that would pump the manure inside over there. The manure has to be kind of nicely spread. The more it looks like natural, the better. To have more air between them, that's good. So those larvae could kind of fall into the crevices and develop and grow up. And as you could see here, is how you how you collect them. They fall off and they kind of wiggle themselves right into the container. You could see over there the openings in this wall. They're in between two belts. Well, that opening is actually for the air. So air is pumped here, there, and there. It circulates like this. So it's only 6 feet that I have to worry about. Now here is the picture, but it's not really nice picture. I don't think you could see much, but basically this is exactly what is over there on the sketch. Now I'm starting to sell. I'm starting to sell licenses for the use as a territorial license, and people are already inquiring. People are actually even making offers. The most active are Chinese. I think they have the biggest problem possible, because they produce more eggs than well, not more eggs, but 40-something% of eggs produced on this planet was in China, and they have mountains of manure. United States is not bad as well. They have 100 times per day manure. Is not a big rarity. Like it is actually a commonplace in United States, and that means a mountain of manure every day. Yeah, you could spread it around, but it is just, when you spread it, you just spread the problems around. This way, there is no problem. It is complete elimination of the problem. The farm would be, the farm, meat producing, egg producing farm would be ecologically neutral place. There will be nothing to dispose. I do not dispose anything, absolutely anything. It comes here as a manure. I produce my own larvae. Larvae become food for the chickens, because they're protein, and the rest of it become fertilizer. Only the water is gone and the water evaporates from the apparatus. So this is the technology that I developed. Another thing why the fly larvae are so beneficial is that if you use another insect, let's put it this way, there are insects that are also kind of good recyclers. Mealworms, they're produced by the beetles called, I believe, darkling beetles. Darkling beetles and mealworms, which are their kind of larvae stage, highly diseased. They transfer diseases, and they're a big problem, especially in this industry, in the egg layers or the meat producing industry. They go into the food. Yeah, they're recycling. You don't want them to recycle your food, chicken food or something. And they transfer all kinds of diseases. They eat dead mice, the mice that when they're alive, they eat them, and mice die, they eat them. And they take about 30 days to process this. So having a big cache of organic food and using those darkling beetles or those larvae, mealworms that are called, in 30 days you are infested over there with cockroaches, you have over there mice, they live and die over there, rats and everything, and all of them are known as the disease carriers. So they just, whoever is using organic fertilizer have to kind of worry about those things. Organics, they could easily carry the disease, especially if they're used if they're made out of the insects who are known as a disease carrier. So be careful when you're buying. Make sure that people tell you what insect they're using, make sure they know what material they're using, and make sure that you know who are they, what are they, do they know what they're doing? Because if they don't know what they're doing, sooner or later you're going to get sick from using that fertilizer. So this is why I would suggest people buying organic fertilizer, to address those questions to whoever is selling it. What insect are you using? Because if it's not some insect, like if you use, let's say, the grasshoppers, they're not so bad because they're not known as a disease carrier. They could still carry it, but it's not likely that you're going to have any problem. They call it frass. It is insect poo, basically. So, as I say, yeah, if you know that's made from the species that are not so bad, but the species that actually kill bacteria are fly larvae. So this is the reason I decided to go fly larvae, because I'm not afraid that somebody is going to get sick using my fertilizer.